What happens when classical machine learning meets quantum computing? The idea is pretty simple. Classical data goes in, quantum computation happens, and a classical prediction comes out. For this experiment, I created a synthetic dataset using scikit-learn's make-moons dataset. It has 100 samples, 2 features, and 2 classes with a non-linear relationship. Visualize the data so I could understand the classification problem before bringing quantum computing. Just like traditional machine learning, I started with preprocessing. I scaled 2 features between 0 and pi because I wanted to use those values as rotation angles inside the quantum circuit. Now things get a bit more interesting because I have 2 features. So I use 2 qubits. Feature 1 controls an Ry rotation on the first qubit. Now feature 2 controls another Ry rotation on the second one. And then I use a Cx or a control X gate to introduce an interaction between 2 qubits. So essentially feature 1, that is the qubit 1, then feature 2, qubit 2, and then the qubits interact. Now comes quantum probability. A 2-qubit system has 4 possible states, right? 0, 0, 0, 1, 1, 0, and 1, 1. For one of my samples, I got 0 as 1.79%, 0, 1 as 31.47%, 1, 0 as 0.85%, and finally for 1, 1, I got 65.89%. Now let's see the visualization. So in this particular example, the 1, 1 state has almost a 66% probability. Now comes prediction. For this beginner demonstration, I'm using the probability of 1, 1 as my classification signal. If it's at least 50%, I classify it as class 1. Since I got almost 66% here, my prediction is class 1. Some clarification. Now this is not claiming quantum advantage at this stage. I'm simulating the quantum circuit on a very classical computer, and this is not yet a trained quantum neural network or a variational quantum classifier. But that would be interesting. I'll try next. My goal was to simply understand the fundamental bridge between classical machine learning and quantum computation. So don't just watch this, go experiment with it. So here is the question for you. What does your quantum probability distributions look like? Experiment with your own data and let me know what probability you got for 1, 1. See you in the next one.